Welcome back, class. I'm Mr. Teacher with the SAT Math video guide, and I just realized something after finishing the recording of the last video, that at number 12, the question never says that the distance between any 2 points has to be greater than 0. That means the length between BC can be 0. So the range is something like 0 is less than or equal to x, which is less than or equal to 1.5. Any number within that range. So it could be 0, it could be 1.5. So just making sure of that, because it could also be a number I didn't include. So let's move on to number 13. Okay. In the 30-day month of April, for every 3 days it rained, there were 2 days it did not rain. That's a very rainy season there. The number of days in April on which it rained was how much greater than the number of days on which it did not rain? So for every 3 days it rained, there were 2 days it did not rain. So the cycle, the entire length of the cycle, so 3 days it rains, 2 does not rain. So each cycle is going to be equal to 5 days. And so first we need to find out how many cycles there are going to be in the month of April. So it's 30, which is the total number of days in April, divided by 5, which is equal to 6. So this pattern is going to repeat itself 6 times. So 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, 3, 2. And that's where it's going to stop. So how many days did it rain? Well, how many times in the cycle did a rain cycle go? So 1, 2, 3, 4, 5, 6. 6 times 3 is 18. So a total of 18 days it rained. And to find out the days it did not rain, just count the number of 2's in the cycle, 6, multiplied by 2, so you get 12. 18 days it rains, 12 days it did not rain. And how much greater is the number of days raining than the number of days not raining? Just subtract the 12 from the 18 and you get 6. So that's the correct answer. Let's move on to number 14. Oh, I've run out of space. Here, let's fix that right now. I'm sorry. Come on. There we go. Let's go to number 14. 14. So, each term of a certain sequence is greater than the term before it. If the difference between any two consecutive terms in the sequence is always the same number, why did I say if? The difference between any two consecutive terms in the sequence is always the same number. Okay. If the third and sixth terms of the sequence are 17 and 77 respectively, then what is the eighth term? So it's going to be like this. First term, second term, and then third term is 17, fourth term, fifth term, sixth term is 77, seventh term, eighth term is x. We're going to try and find x. So from 17, it takes three spaces to go to 77. So what's the difference between 77 and 17? Well, it's 60. You subtract 17 from 77. So it takes three of these places holders to go to 77 from 17. And they must equal 60. And since the distance is equal, so if we divide 60 and if we do 60 divided by 3, we get 20. So each time it goes up by 20, or the difference is 20. So this is 37, this is 57. Likewise, after 77, this is 97, and this is 117. So x equals to 117. Next problem. Number 15. Oh, no. I'm sorry. I'm making a lot of mistakes in this video. Number 15. So the absolute value of x minus 3 equals to 1/2. So what is the least value of x that satisfies the equation above? Well, what do we know from absolute value? If the absolute value of x minus 3 equals to 1/2, then we know that x minus 3 could equal to 1/2, not absolute value in reality, or x minus 3 could equal to minus 1/2. So now let's solve these equations. The first one goes to x equals, we add the 3 to both sides, 3 and 1/2. And this one, we do x equals, we still add the 3, but to negative 1/2, so it ends up to 1/2, so that's 2.5. And since this is the lower value of the 2, this is the answer. But keep in mind, you cannot give it as a mixed fraction, so you can give either 5/2 or just 2.5. So either one of these is the correct answer. They're the same value, and you can pick either one, whatever you fancy. So number 16, we're nearing the end of this section. Number 16. A 4-digit integer w, x, y, z, in which w, x, y, and z each represent a different digit, is formed according to the following rules. So number 1, x equals w plus y plus z. The number 2 rule is w equals y plus 1. And the third rule is z equals to w minus 5. So, what is the 4-digit integer? Well, we need to try and find assume a value for the least number, because when you start with the smallest number, it becomes easier. And judging from what we can see, since z equals to w minus 5, z could very well be the least number. So let's say z equals to 1. So then w minus 5 equals to 1, and w equals to 6. And w equals to 6, y plus 1 is going to equal to 6. Y is going to equal to 5. So y is equal to 5. And x is going to equal w plus y plus z. So that's 6 plus 5 plus 1, which is 12. And that's going to be impossible because that's not a single digit. So the only other smaller value we can pick for z is 0. So let's say z equals to 0. So w minus 5 will equal to 0. W equals to 5. So let's cut this off. We don't need this. W equals to 5. W equals to y plus 1. Y plus 1 is going to equal to 5. Y equals to 4. And x equals to w plus y plus z. So that's 0 plus 4 plus 5, which is 9. So that actually makes sense. They're all single digits. So the number is 5940, which is w, x, y, z. So this problem just seems very hard because there's so many variables that we don't know the value of. But if you pick a number, it usually gets easier. And okay, number 17. And there's a drawing here. So let's draw it. Something like this, and this. Okay. Ooh, loose end. It wasn't even ever there. Okay, back to, so this is A, this is B, this is C, and there's a point here, this is D, and there's a, oh, here, I forgot to draw something. This goes like this, this goes like this, so this is D, this is E, and this is F. And, okay, note figure not drawn to scale. The flag above is made of overlapping equilateral triangles. So, okay, ADF and BCE. Because ribbon is to be sewn around the entire outer edge, it is necessary to know the perimeter of the flag. If CD, the line CD, line DE, and line EF each have length 10 inches, what is the length in inches of the perimeter shown in bold? So this is 10, this is 10, and this is 10. Now, since we see these dashed lines, we see that line DE plus line CD is line CE, but that's part of equilateral triangle BCE. So since 10 plus 10 is 20, this is also equal to 20. And the same thing with this triangle here, 10 plus 10 is going to be equal to 20. So over here. And now we know that this is 60 degrees. Just let's keep that in mind. 60 degrees. 60 degrees. And another 60 degrees. This is also going to be 60 degrees because it's the overlapping of two equilateral triangles. So like this. And we know then that this length is also going to be equal to 10 because this is the same triangle. 10. And if that's 10, then this line AD has to equal 20. So this is 10. Line BE has to equal 20, so this is 10. So now we just add up the outer perimeter. So line CD plus DE plus EF plus FA, then plus line BC, and plus these two little angles on the side. So that's 10 plus 10 plus 10 plus 20 plus 20 plus 10 plus 10. So that's 30, 40, 20, add them up, it's 90. So the perimeter of this figure is 90. And we're gonna finish up the last problem right now, hopefully. So let's do it. Number 18, and there's a parabola here. So let's draw the graph. Y, X, and it's okay. Dum bum bum bum. 3 up here, 2 here, and okay. So the parabola goes like this, and hopefully I could draw it with freehand. You'll understand, like that. Okay, that looks very messy. Well, you know what? Actually, I've run out of time, and well, next video we'll start on the next section and finish up with number 18 because it's a bit complicated. It's the last question in the section, so I hope the rest of this video helped you with your math preparation. We will finish up on number 18 next time in the next video. I hope to see you soon.